Okay, we'll get back to section 11.10 here. We're on this example where we're going to find the Taylor series for f of x equals 1 over x at a equals 1. By the way, we cannot find a Maclaurin series for f of x equals 1 over x because the a value is 0 whenever you're finding a Maclaurin series, and f of a is the first term, and you can't divide by 0. You can't divide by 0 on any one of these, okay? So a Maclaurin series does not exist for 1 over x. That's okay. So we'll find the Taylor series then. So f of x is 1 over x. F prime of x, so I'll find the derivatives here first. F prime of x is using well, let's see, 1 over x, that's the same as x to the negative first power, right? So then negative x to the negative second power, or negative 1 over x squared, would be the first derivative. And then negative x to the negative second power, when I take the derivative of that, I get 2x to the negative third power. It's the second derivative, okay? 2 over x cubed is the same as 2x to the negative third power, right? And then take the derivative of that. So I get 2, and then times the negative 3. I'm gonna keep the that's negative 6, right? I'm gonna keep this as is though, just because of a pattern that we're gonna see. And then divided by or times x to the negative fourth is the same as divided by x to the fourth. Okay. And then the fourth derivative, let's see, I got negative 2 times 3 times x to the negative fourth. That'd be the same thing like when I take the derivative of that, bring down the power of negative 4. So I got negative times negative would be positive then. Right, so 2 times 3 times 4 times x to the negative fifth, or 2 times 3 times 4 divided by x to the fifth. Okay, etc. So what's going to happen here is that up top we'll alternate sign here. So we got it goes negative, positive, negative, positive. You know, the next one's mean negative. So that's the meaning of the negative 1 to the n. Okay, and then let's see. The fourth derivative, I got 4 times 3 times 2 times 1, right? Third derivative is 3 times 2 times 1. The second derivative is 2 times 1, right? The nth derivative will be n times n minus 1 times n minus 2 times etc., or that'd be the same thing as n factorial. Okay, and you're dividing by x to the whatever the number derivative you're on. It looks like the power is going to be 1 more than that. Okay, so I'm going to have if I'm on the nth derivative, I'm going to have the power of n plus 1 there. Okay, so then let's see, the Taylor series, a is 1. So when I plug in 1 into the nth derivative, then the denominator is going to be 1. Okay, and we're going to have negative 1 to the n times n factorial. So then 1 over x, written as a Taylor series, would be the nth derivative of f at 1, and then times x minus 1 to the nth power divided by n factorial. Okay, and so let's see, when we simplify that, the nth derivative of f at 1 is negative 1 to the n times n factorial. The n factorials would cancel then. So I'm going to have negative 1 to the n times x minus 1 to the n. I got the summation of all that. And let's see, when I expand this out, so when n is 0, anything to 0 power is 1. When n is 1, I have minus x minus 1. When n is 2, I have plus x minus 1 squared. When n is 3, I have minus n minus 1 cubed. Okay, and so you know we're going to alternate sign here, plus etc. Okay, so this would be the Taylor series for 1 over x. Okay, so 1 over x is the same thing as 1 minus x minus 1 plus x minus 1 squared minus x minus 1 cubed plus x minus 1 to the fourth, etc. Okay? All right. There's some problems in the section where you're going to find the first three non-zero terms in each of the Maclaurin series. So I've just got two examples here where we're doing that. So part A, I got e to the x times the arctangent of x. And then part B is tangent of x. So let's just find the first three non-zero terms in each one of these series. Okay, now we're not asked to give a formula. Okay, that'd be a different question. We just want to find like what are the first three terms going to be? Okay, so let's see. If I use the Maclaurin series for e to the x and the Maclaurin series for the arctangent of x, so we saw the Maclaurin series for e to the x in that was the first example that I showed you in this section here. That's the summation as n equals 0 to infinity of x to the n divided by n factorial. And then times the power series for arctangent of x, that we saw that in the last section in 11.9. That's the summation as n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 divided by 2n plus 1. Okay, and when I expand both of these out, so when n is 0, 0 factorial is 1. Anything to the 0 power is 1, so I'm going to get 1 for the first term. When n is 1, I'm going to have x divided by 1 factorial. When n is 2, I'm going to have x squared divided by 2 factorial. When n is 3, I'm going to have x cubed divided by 3 factorial, plus etc. Okay? And then multiplied by, let's see, when I plug in the numbers here, when n is 0, I have 1 times x divided by 1, that's x. When n is 1, I'm going to have minus x to the third power divided by 3. Okay, and then when n is 2, I'm going to have plus x to the fifth divided by 5. Okay, and then minus, so that I get an alternating series there, right? Etc. Okay, now I'm multiplying these two things together. So let's see, when I begin that, I'm going to take 1 times all this plus x times all this plus x squared divided by 2 factorial times all this plus x cubed divided by 3 factorial times all this, right? So let me begin doing that. Okay, I got 1 times all that would be x minus x cubed divided by 3 plus x to the fifth divided by 5 minus etc. Okay, plus when I distribute x into all infinitely many of these terms, I'm going to have x squared plus x to the fourth over 3 plus x to the sixth over 5 minus etc. Okay, and then when I distribute x squared over 2 factorial into all infinitely many of these terms, I'm going to have x cubed over 2 is the same as 2 factorial, plus, let's see, x squared over 2 times x cubed over 3. X squared times x cubed, let's keep the base and add the powers there. So I got x to the fifth over 2 times 3 is 6. I'm subtracting that, right? And then x squared over 2 factorial times x to the fifth over 5. X squared times x to the fifth, again, keep the base and add the powers. That'd be x to the seventh. Divided by 2 times 5 is 10. Okay, minus etc. Okay, so this is what I have so far. Now, all I want to know is the first three non-zero terms. So what are the first three terms going to be? Well, let's see. I've got x, and I don't have any other terms just involving x, so x is going to be the first term. Plus x squared, and I don't have any other squared terms. Okay, and then here's a negative 1/3 x cubed plus 1/2 x cubed. Negative 1/3 plus 1/2. Let's see, the common denominator would be 6. So negative 1/3, that's same as negative 2 over 6 plus 3 over 6. That's 1 over 6 x cubed. Okay, so plus 1/6 x cubed plus etc. Okay, so there's the first three terms in that series. Okay, now the reason why we're doing this is because there is no convenient way to write this as a power series. Okay, so you just got to multiply these two known power series to get the result there. Okay, and so here's what the first three terms look like. Okay. Now in part B, I want to first find the first three non-zero terms of tangent x. Okay, well, tangent x, that's the same as sine x over cosine of x, and I know the Maclaurin series for both of those guys. So sine x is the summation as n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 divided by 2n plus 1 factorial. And then cosine of x is the summation as n equals 0 to infinity of negative 1 to the n times x to the 2n divided by 2n factorial. Okay, so then when I expand this out here, both of these, n is 0 means that I got 1 times x divided by 1 is x. Okay, when n is 1, it's going to be minus x cubed divided by 3 factorial. Okay, when n is 2, I'm going to have plus x to the 5th divided by 5 factorial. Okay, and the series is going to alternate sign, right? So it'll be minus, etc. Okay, and I'm dividing that by cosine of x. Well, if I expand that out, when n is 0, I have 1 times anything to 0 power is 1, divided by 0 factorial is 1. Okay, so the first term is 1. When n is 1, I'm going to have minus x squared divided by 2 factorial. When n is 2, I'm going to have plus x to the 4th over 4 factorial. Okay, minus, etc. So again, I got an alternating series here, so it's going to alternate sign. Okay, now I'm dividing these two things. So just if I go back to regular division like I'd see in an algebra class, the expression that's in the denominator is going to go outside the division bar, and the expression in the numerator is going to go underneath the division bar. Okay, so I got 1 minus x squared divided by 2 plus x to the 4th divided by 4 factorial. 4 factorial is the same as 4 times 3 times 2 times 1. That's the same as 24. Okay, and underneath the radical, let's say I've got x minus x cubed divided by 3 factorial. That's the same as 3 times 2 times 1, that is 6. Okay, plus x to the 5th divided by 5 factorial. 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1. When you simplify that, that would be 120. Okay, so here's what I'm dividing so far. Okay, now let's see. I'm trying to think of a term so that the leading term is going to be x. Okay, when I multiply it by all this. Well, if I just take x times 1 is x. X times 1/2 x squared, that'd be 1/2 x cubed. And then x times 1 over 24 times x to the 4th, that'd be 1 over 24 times x to the 5th. Okay, now again, I would be subtracting all this, so I'd have to throw a minus in front of all these signs here, or change all the signs to their opposites. X minus x is 0. Negative 1/6 x cubed plus 1/2 x cubed. Let's see, negative 1/6 plus 1/2. 1/2, that's the same as 3 over 6. So I got negative 1 over 6 plus 3 over 6, that'd be negative 2 over 6, or sorry, 2 over 6. Or 2 over 6 is the same as 1/3. So I get 1/3 x cubed, and then 1 over 120 minus 1 over 24 is, let's see, so just typing that in here. I'm getting, let's see, 1 over 120 minus 1 over 124, that's, I'm getting as a fraction, it'd be negative 1 over 30. Okay, so I got minus 1 over 30 x to the 5th, and then plus, etc. I don't care about the rest of those, right? Okay, so then the next term, let's see, I'm thinking of a term so that an expression so that the leading term gives me 1/3 x cubed. So I got a 1/3 x cubed leading off right there. Well, if I just take 1/3 x cubed times all this, then the leading term is 1/3 x cubed. Okay, so 1/3 x cubed times 1 is 1/3 x cubed. 1/3 x cubed times negative 1/2 x squared. Okay, so x squared times x cubed, I keep the base and add the powers, that'd be x to the 5th. 1/3 times negative 1/6 times negative 1/2, that'd be negative 1/6. Okay, and then plus, etc. I don't really care what the rest of this is. So I could keep going, you know, just it's not necessary though, because all I need to do is find the first 3 non-zero terms. So I've got the first 2 here so far. So then the next thing would be I'm subtracting this. So take 1/3 x cubed minus 1 over 30 x to the 5th plus, etc. Then minus 1/3 x cubed plus 1/6 x to the 5th minus, etc. Okay, so 1/3 x cubed minus 1/3 x cubed, that's 0. And then if I take negative 1 over 30 plus 1/6, let's see, as a fraction, I am getting 2 over 15 when I do that. Okay, so I got 2 over 15 x to the 5th as my next term, okay, plus, etc. So if I multiply all this by 2 over 15 x to the 5th, then the leading term would be 2 over 15 x to the 5th. Okay, so that'd be the third term there. All right, so tangent x, in other words, that's the same thing as x plus 1/3 x cubed plus 2 over 15 x to the 5th plus, etc. Again, this is an infinite series here. This would just be the first 3 non-zero terms, though. Okay. All right. I'd like to finish up the material in the next video. So we just got a couple more examples here, and then we're all done. And we'll hit that in the next video there.